Okay, Assalamualaikum and hi everyone. So today, I think by now you should have already seen a 6.1 video, which is operations and how to use a long division. Okay, so for this video, we are going to see a second subtopic, 6.2, where we are going to see how to do a remainder theorem, factor theorem, and root and zeros of polynomials. Okay, so for this video, we are going to focus on what is a remainder theorem. Okay, so now let's see. We have subtopics like 6.2 remainder theorem. So what is a remainder theorem? Okay, back to what we have already learned from long division. This is how we express our polynomial. Okay, there are two ways. So let's see this part. Px is equals to dx, qx plus rx. You should already know what is qx, what is rx, and what is dx. So now let's write that expression again. So we will have px equals to qx dx rx plus rx. Okay, remember this. And then what is a remainder theorem? Stated here, if a polynomial px is divided, okay, the keyword here is divided, which means that is your divisor, by a linear factor x minus a. So this is your divisor, then the remainder is pa. Okay, so what does it mean by that? Let's see. If we have by using this formula, let's say your divisor is x minus a, so we are going to have our x is equals to a, right? Then we will have pa is equals to qa. So dx is your divisor, which is x minus a. Then if your x is equals to a, so this will be a minus a. Okay, multiply by a minus a, multiply by a minus a, okay, plus ra. So as you can see from here, a minus a, we are going to get 0. So all of this will be 0. So we are left with pa is equals to ra. So what is ra? Ra is a remainder of your polynomial. Okay, so now let's see. Let's just go to the first example. We have find the remainder when px, a polynomial, is divided by x plus 3. Keyword here is divided. Okay, so we know that we have to use a remainder theorem here because we want to find our remainder. So this is x plus 3. The root here is x equals to negative 3. Okay, so just substitute into our polynomial. P negative 3 is equals to negative 3 power 4 plus negative 3 cube minus 2 negative 3 square plus 4 negative 3 minus 5. Okay, tekan calculator. Tekan calculator dulu, pause video, press your calculator. You should have get 19. Okay, so by using your remainder theorem, this is your remainder lah. Okay, because we know that our remainder theorem, we conclude that our remainder theorem pa is equals to ra if x minus a is our divisor. Okay, so now we can conclude that the remainder of px is equals to 19. Okay, alright. So now we have 3x minus 1, which is your root here is x equals to 1 over 3. So we will have p 1 over 3 equals to 1 over 3 power 4 plus 1 over 3 cube minus 2 1 over 3 square plus 4 1 over 3 minus 5. Okay, please press your calculator. You should get negative 311 over 81. And we can conclude that our remainder rx is equals to negative 311 over 81. Okay, so that is your remainder theorem. Okay, if you have a divisor, if your polynomial is divided by a linear factor, then your pa is equals to ra. Okay, so now let's proceed to the example 5. We have a polynomial here is divided. Keyword here is divided by x plus 2, which is the root here is x equals to negative 2. And it is given to us that the remainder is 16. Okay, so let's write what do we have here. We have P. We know that PA is equals to RA. And then we have our divisor with root x equals to -2. P -2 is equals to RA, the remainder. So it is already given to us. The remainder is 16. So we have P -2 is equals to 16. So this is your remainder theorem. Now what you need to do is just substitute into the polynomial. Substitute -2 into your polynomial. We will have plus 5 -2 square minus 6 -2 minus 8 equals to 16. Okay, then just simplify here. 16 plus 20 plus 12 minus 8 minus 16 should get 24. Here is 8k, so your k is equals to 3. Okay, so now you can find a constant in your polynomial by using remainder theorem. Okay, now let's see one more example. Example 6 here, we have a polynomial left a remainder of -8 when it is divided by x minus 1. Okay, we have remainder -8 when divided by x minus 1. Keyword here is divided, so we can use remainder theorem here. Or we can just put it as the first one, we have P1 is equals to -8. Okay, so the second sentence here, we have a remainder of 11/2 when divided by 2x plus 1. Okay, by using remainder theorem as well, we have P, this one your root is -1/2. We will have -1/2 is equals to 11/2. So question asks to determine the value of A and B. So what you have to do, just simultaneous equation. Okay, substitute into the polynomial. So first we substitute 1 into this polynomial. You should get A1 to the power of 4 minus 5 1 cube plus B1 square minus 7 1 plus 1 equals to our remainder, which is -8. Okay, ini bawa sana sikit. So now just simplify. We have A plus B equals to 3. Okay, so kira dulu kamu boleh pause video and calculate by yourself first, then check your answer. So we have A equals to 3 minus B. This is our first equation. Now let's proceed to this part here. Sama juga, just substitute into our polynomial. Minus 5 -1/2 cube plus B -1/2 square minus 7 -1/2 tak muat pula plus 1 equals to 11/2. So just calculate our answer here. We should have 1/16A plus 1/4B equals to 3/8, and then we can simplify, multiply everything by 16. We will have A plus 4B equals to 6. So this will be our second equation. Okay, so we can just do simultaneous equation by using substitution. If you want to use elimination, also can, no problem. So now we just substitute equation 1 into 2. So we will have 3 minus B plus 4B equals to 6. Okay, -B plus 4B, we will have 3B equals to 3B is equals to 1. So already get our B, and then just substitute into equation 1 back. We will have 3 minus 1 equals to 2. Then we have our answer, A equals to 2 and B equals to 1. Make sure you write your final answer. Okay. Alright, so let's proceed to the next part here. Okay, as you can see here for this part, our divisor, our divisor here divided by a linear factor. Okay, linear, power 1 kan, x. Now let's see, when a polynomial is divided by a quadratic expression, then the remainder is Rx equals to Ax plus B. Okay, back to the previous video, as I said, when you do your long division, when are you going to stop? When your remainder power dia kurang 1 daripada kita punya divisor. Okay, that means this is your remainder. Okay, kalau kamu punya divisor power dia 2, degree dia 2, your remainder degree dia 1. Okay, dia mesti kurang 1 daripada kita punya divisor. That is why if you have your divisor quadratic, then your remainder should be ax plus b. So ini maintain lah rx is equals to ax plus b. Okay, kita ingatkan balik, degree remainder kurang 1, less 1 power, less 1 than divisor. Okay, as you can see when we do our long division. So that means if we have our x is equals to a, we will have so we have rx is equals to ax plus b. Okay, that's it. So now as you can see from the previous statement here, I said that this will be 0, so that means this also will be 0, and then we are left with px equals to ax plus b. Okay, so we have our px equals to ax plus b. Alright, so let's say example 7. Maybe kamu macam confused lagi sekarang. It's okay. So we have determine the remainder when a polynomial keyword is divided. So you know that you have to use remainder theorem. Divided by x squared minus 1. So let's write everything we have. We have our px is equals to 3x power 4 plus 5x cubed plus x plus 6. Okay, and then it's divided by x squared minus 1, which is your divisor. X squared minus 1, we can simplify, we can factorize, which is we will have x plus 1, x minus 1. Okay, so now your root is x equals to negative 1 and x equals to 1. Okay, so let's see now, let's just start from here. We have our general expression there. We have px is equals to qx dx plus rx. Okay, so now let's see our divisor. We know that this is our divisor. Okay, x squared minus 1. So we have px equals to qx x plus 1 x minus 1 plus rx. Okay, let's say if I take x is equals to 1, when x equals to 1, okay, so we're going to substitute 1 into here, into all of this part. As you can see, if I substitute 1 into here, this will be 1 minus 1. So all of this will be 0. So again, we are going to come back with px equals to rx. But remember that our divisor is a quadratic, so you know that your rx should be a linear. Ax plus b. Okay, boleh faham ke? So now we know that our rx is supposed to be ax plus b, so we are going to change this into ax plus b, and all of this will be 0. Okay, so now we are going to end up with p1 is equals to a1 plus b. So p1 here is just substitute your 1 into this polynomial here. So we are going to have 3 1 power 4 plus 5 1 cube plus 1 plus 6 is equals to a plus b. So now just simplify, we will have a plus b is equals to 15 and a is equals to 15 minus b. So this will be our first equation. Okay, so ini sebenarnya tak perlu buat lah. So you know that when your rx, when your divisor is a quadratic, your remainder supposed to be a linear. Okay, mesti kena linear. So by using a remainder theorem, your PA is supposed to be ax plus b. Okay, if your divisor is a quadratic. Okay, so now let's proceed to the other one, root, which is x is equals to negative 1. So we will have when x equals to negative 1. So just substitute, we're going to have p negative 1 is equals to ax plus b. So we will have a negative 1 plus b. So just substitute into the polynomial again. 3 negative 1 4 plus 5 negative 1 cube plus minus 1 plus 6 equals to negative a plus b. Okay, now here on your left hand side we are going to get negative a plus b is equals to 3. Okay, so this will be our second equation. So now just substitute. One into 2. So here we will have 15 minus b, negative 15 minus b plus b equals to 3. And then we have 2b equals to 18. And then your b is supposed to be 9. Then straight away we are going to get our a. A is equals to 15 minus 9, which is equals to 6. Okay, so then the question asked for a remainder. So we know that our remainder is ax plus b. So let's give our answer. We have our a and b, so the remainder is 6x plus 9. Okay, so that is how you use your remainder theorem if your divisor is a quadratic. So your remainder should be a linear. Okay.